All right, hello and welcome to problem 6.10, the problem of the guy pulling a box along the grass. Let's take a look at this problem. The problem asks us to find the acceleration. Well, we know that acceleration is equal to net force divided by mass. So first we need to find the net force on the guy. So finding the net force of a two-dimensional problem, you always start with a free body diagram. So looking at this block, we realize gravity is pulling down. We'll call it Fg. We know that he is pulling at a very shallow angle, and we'll call that Fa for just an applied force. And then we have the normal force pulling up. We'll call that Fn. And then we have the force of kinetic friction pulling to the left because he's moving to the left. All right, before I do anything, I like to break up the forces into their components. Okay, look at Fa real quick. Imagine if the sun were shining over here. The sun would shine and cast a shadow along the y-axis that would be this long right here. All right, now it's kind of overlapping f of n, so we could draw it right here instead if you like to make it a little bit more out of the way. And we're going to call that f of a, right? F of a that's in the y direction. Now, imagine if the sun was up here, shining down on this vector. It would cast a shadow on the ground that looks like this, and we would call that F A in the x direction. All right, so now we have our Fay and our Fax, and we can move this force out of the way just because it's kind of getting crowded over there. So now that we have the net force in each direction, or not the net force, we have the component in each direction, we can start to solve for what we need. All right, the first thing we do is we do the sum of forces in the x direction. Now, we don't know the sum of forces in the x direction, but that's what we're looking for, sum of forces in the x direction. And we know the net force will be in the x direction because there will be no forces, or no sum of forces in the y direction. So the net force in the x direction will equal Fax minus the force of kinetic friction. All right, that's it. Okay, so going out at this a little bit more, we see that Fax is equal to Fa times the cosine of theta. Both of those are known, minus the force of kinetic friction is equal to the normal force times the coefficient, which is known. Okay, things in red are unknown, green are known. So continuing, we have Fa, which is 300 newtons, times the cosine of, let's see, what angle was it? 27 degrees. So times the cosine of 27 degrees minus the unknown normal force times the coefficient was 0.4. So all we got to do in this whole problem is find the normal force, and then we're done. So to find the normal force, we need to go to the forces in the y direction. The sum of forces in the y direction is known. It's equal to 0. So the sum of forces in the y direction is equal to 0, which is equal to our unknown normal force plus the force of A in the y direction minus the force of gravity. Those are both known. Everything's known except, check it out, F of n. So let's keep plugging some stuff in. So we have Fn plus Fay, which is simply equal to F A times the sine of theta. minus mg. Okay, keep going. So we have the normal force, plus Fa, which is 300, times the sine of 27 degrees minus the mass, which was 17 kilograms, times 9.81 meters per second squared. All right, and you do all of that, scroll it down, and you get out the net force plus, let's get our calculators out, 300 sine of 27 minus 17 times 9.81 comes out to be 30.5 newtons, and that's negative. All right, negative 30.5 newtons. And all this still equals 0. Therefore, the normal force is now known. Normal force now equals 30.5 newtons. Cool. Now we can take it and we can plug it back in up here to what we're looking for. So let's move all of this down. Now we have the net force in the x direction is equal to 300 cosine of 27, which is equal to 267 newtons, minus the normal force, which is 30.5 now, is what we calculated, newtons, times 0.4. When we do that, we get 267 minus 30.5 times 0.4. We get out a net force of 254.8 newtons. That is our final answer for the sum of forces in the x direction. So here's our object. We have one net force in the x direction of 254.8 newtons. Thus, finding the acceleration, you get acceleration is equal to net force divided by mass. So we have 254.8 newtons to the right divided by 17 kilograms. And you get out roughly 15 meters per second squared to the right. That's your final answer. Good work, guys.